This video represents my personal opinion. Heidi ho, David the Benj here. Today we're taking on another chapter of the Cush Chronicle. Today we have the ultra fun subject of server infrastructure and replication strategies. Today I'm joined by Tamer. Say hey, Tamer.
Hey guys.
He's in Florida and I am up in Seattle doing this episode, so we're virtually connected. So first off, we're going to talk about our server architecture. So we'll start off the topic today with the server infrastructure. The server infrastructure for this first pass of the communities.adobe.com is fairly simple server-wise. We have one author, and then we have 4 publisher servers. On each of the publisher servers, we have a dispatcher cache, and an Apache HTTP server. In front of all 4 of the published servers, we have a load balancer. Pretty simple setup, 4 publishers. I believe that we have about 32 gigs of RAM on each of the publishers, so there's some pretty substantial boxes. We have one author, which is, we don't do a lot of authoring per se in a social in the community site. There's just small things from time to time, maybe some user management or a request for a new community, but that's about it. Now, we had some decisions to make as far as replication goes. UGC and just social as a whole. The activity will happen on node A, and then you want to see it on the rest of the servers almost instantaneously. There's a lot of communication or writing going on across these servers. To be able to support this, you have to have a replication strategy, right? And we had a couple different scenarios come up where in the past where we've tried to do this and we've used reverse replication and it wasn't quite as efficient, and we've had some problems with it here and there, and it was just very noisy, and we wanted to go with something a little bit different. So we did what's called a peer-to-peer replication. And Tamer, do you want to take us through this diagram some, or do you have a different diagram you wanted to show?
No, this actually diagram works perfectly. Okay. Let's consider the publish instances 1 to 4 from left to right, as well as the author is the little bottom one that's in San Jose. So what we did as a peer-to-peer, if, say, for example, a user is actively putting in content from the publish side on server 1 in Dallas, what ends up happening is server 1 actually communicates to server 2, 3, 4, and publish. And it'll replicate out to all 4.
Did you mean author on that last?
Sorry, and author on the last one, yes.
Yeah,
so
okay.
Server 2, 3, and 4 of publish and author are single author, and it'll replicate to all 4 of those instances instead of doing the normal reverse replication. With this, we ensured that when a user is entering in information, his information isn't lost if he comes and accesses it from another server.
And how did we, when you get this out of the box, it comes set up for basically for reverse replication, right? What did we have to do to take care of this? So as I understand it, we turned off the default agent, and then we put in a custom agent. We'd go in and configure an agent for each of the different servers. So we had so on host A, we would have an agent for host B, C, D, and author, right?
Exactly.
And then we would check the on distribute flag on those agents. But could you explain a little bit into what managed the replication? How does it know when to replicate? What's managing the replication process?
Okay, yeah, no, that's not a problem at all. Actually, what ends up happening is for every replication agent, you would create one per instance that you want to replicate to. The big thing is when you set these up, you want to have what it's called, since you're not doing reverse replication and you disable the reverse replication, you're doing CQ distribute at this point. CQ distribute flag, it's actually under triggers. It's on distribute, and if you check it, the agent will auto-replicate when content's marked for distribution since it's been modified. So with that, say a user comes in and creates an event on, again, publish instance 1. When we create that in UGC, we mark it with a CQ distribute flag to be true. Now, at that point, the publish instance will notice the CQ distribute, see that all the 4 instances, that the 3 publish and the 1 author, are on CQ distribute, and once they find that content, it will distribute it automatically. So that way you don't actually have to worry about replicating which one's getting replicated. It's very simple, just adding that CQ distribute flag to whatever content you want to be replicated.
Now, was that handled automatically? So I know the CQ distribute flag or property was put on the node when you save it to tell it to trigger replication, but was that replication, was it automatically handled by the system, or did we have to put in a custom code to be able to handle that? And then, did we have to, the CQ distribute flag or property, if you push that forward on the node to the next node, is the next node going to see that and then try to redistribute it again?
Yeah, so what we had to do is we actually did create a custom auto replication class that handles it. I do believe out of the box it does handle it, but we needed some more functionality. And part of the main functionality we needed, we just wanted to make sure that we're not overriding changes across the instances. And that's where we created a checksum property to be put on top level nodes for the home users, and that would calculate if content has been changed on the lower level. So the home users came as a full package, and you would actually replicate the whole user rather than just one piece of content, and that was controlled through the checksum.
So you're saying on the user, in the user area in particular, when somebody does something, and this is kind of true mostly with users, but when you save something on a user, it's typically not one property that gets updated. It's usually like a bucket of properties, activities, their last login date, the last modified, their expertise, their title, and their address, right? It's not usually just one property. Is that why this was necessary for that?
If we replicated for every property that was changed, if a user updates 5 fields, that's 5 replications right there. Across 4 instances, that's 20 activities. Really, and
it would be 5 replications of the exact same data, right?
Exactly.
Because it would activate the profile node 5 times for the 5 different properties that changed.
Exactly. So what we did is to cut down on replication. We had that checksum, and what it does is it evaluates if there's been a change, but after the event comes through. So you'll get multiple events, and then after all the events come in, it'll say, yes, this user node has to be replicated, and then we'll go off and replicate it 1 time rather than 5 times.
Was there anything else? We put this into use. We spent quite a bit of time, if I remember correctly, working through bugs, getting it to operate properly. I remember there was a lot of scenarios where, we would have to make sure that CQ distribute was on a particular form submission or something, and have to track down stuff. So I know that we put a lot of time and effort into getting this peer replication strategy working. Since we put it in production, what do you think of the results? Are you satisfied with the amount of effort versus the return?
Well, I think part of the effort was actually trying to figure out a couple of scenarios on how it should work and really honing down our replication strategy. It was actually, when you talk about one of the issues we ran into, and this is actually something I didn't think of until we actually had it in production, was the delete case. If you really think about it, when we're evaluating properties, what happens when you delete a property? The property doesn't exist. So what we were doing is evaluating the properties and seeing if the properties had changed, and if so, we would replicate. Now, the interesting issue was when you deleted a property, you can't check if that property has changed, because when you access that property, you get a null pointer. So actually, for some nodes, if you just deleted and you didn't modify anything else, it will get hung up until the next replication, which kind of caused a couple problems. So finding that issue and fixing it, I think that was one of the bigger issues that we ran into, the deleting of all the nodes and the properties consistently. Although the data would sync up sooner or later, if any modifications happen, it's just the risk of, say, removing a follower and not updating because the follower has disappeared as a reference in the social node.
So, Tamer, can you explain to us how we handled the delete issue that we ran into?
Yeah, no problem. So, as we can see, in the auto replication listener, we have events coming in. And this is really the important part. If the event
and this is just standard observation, a standard observation manager that we're using here, correct?
Yes, it's just a standard observation manager that comes with CQ out of the box. And the important piece is here where it says event.property removed and event.node removed. So what was happening, we were trying to evaluate that resource, as you can see here, resource resolver.get resource, but then this would throw a null pointer and break.
Because it's not there anymore, right?
Exactly. So what we end up doing is giving it the parent of that node, and then we give that resource and continue the evaluation. Because we're using the checksum, what ends up happening is a parent not having a child or a node not having a property will return a different checksum. So in other words, it will still realize that it should replicate. And then this really took care of the problem of delete and not throwing a null pointer, as you could see.
Okay. Could you have also possibly, so since the event was removed or node was removed, could you have gone up to the parent and then looked at the parent and then activated the parent? Is that what we're doing here?
Yes. So the way they do it is because, remember, we said you might get 5 property changes. So
yeah,
I consider the parent as the current property. So as it's going through each event, it'll pass, say, if 5 properties were removed, it's not going to activate at that point. It's going to pass the 5 parents, realize that the parents all have changed, and then after all is said and done, then activate. So again, it saves us the issue of replicating 5 times the parent.
Oh, okay. Yeah, right. Was there anything else that you can think of that that other people should know before going down this path? Was it the overall? Are you happy with the results?
Actually, yeah, I'm pretty satisfied with the results. The biggest struggle was realizing really what needs to be replicated and making sure that everything gets replicated. Because sometimes things don't seem that they should be replicated. It's kind of tricky because the CQ distribute flag isn't always there. If you follow a user, it's a press of a button. You can't just necessarily attach it. So realizing, hey, I just followed someone, let's attach the replication to that event. And going through every scenario.
Right. So when this node changes over here, maybe we don't have control over it, but we need to put on the flag for CQ distribute, or we need to handle that event and activate it ourselves.
Exactly.
Just narrowing down all the changes that are made to the system and getting a definitive list and then making sure they're all handled, right?
Exactly, because a lot of the pieces we were using were from other parts of AEM out of the box. So the unfollow was not custom code. So we really didn't have control over how it was added, but we just needed to make sure that when it was added or removed, the follow or unfollow, we replicated properly.
Right. And I have to state this for the audience that this is, we tried to, with this project, stay as close to stock implementation or a reference implementation as we could. The custom peer-to-peer replication, not really probably suggested by the engineering team. In fact, they gave us the head nod on it, but it wasn't their first go-to, right? So, but overall in the project, we tried to stay as much as we could close to the product's feature set or enhancements to the product feature set without just going completely off the grid and just developing our own stuff just from scratch.
Exactly, that fine balance of using what we were provided, but also being able to create at the same time, but not go too far in the deep.
Well, it's one of the reasons for that is also, as we start using these features that came in the box in this really groovy looking Geometrics Outdoors community sample, when you start putting that stuff to the pavement, sometimes you find that the features that engineering spec'd out, once you hit the pavement with them, they don't quite cut the mustard, right? So one of the goals of this project was to go back and write the engineering team, talk to the engineering team. We had weekly meetings with the engineering team to talk about what we were doing in that sprint, and then gaps we were finding. And then as we found the gaps, we would a lot of times work around them and talk about how we worked around them. And then we found that engineering in a subsequent release would put something in that would help address that area, which was great.
Exactly. That was the important part. Is if we felt it wasn't sufficient or it was the harder way to do it, like usual things happen in real world terms, not engineering world terms. We talked to them, we gave our reasonings, and we came to a conclusion together. So what was nice about that is with our weekly meeting especially, we were able to talk about why we went with this direction, and we tried to come to sometimes a middle point, or why they did it some other way, and come to a understanding between us too.
Yeah, and it was interesting to hear them. Sometimes they would go, well, what's that? And we're like, well, they're really asking for this thing, and the customer's really asking for this particular thing to do X, and engineering would be like, what? Why? And you're like, well, I don't know. They seem to find a lot of value in it, and this is what they want us to do. And it really was great seeing them get that feedback directly. It was I don't know. I found it very rewarding to be able to help out and to keep that clear separation between the implementers and the engineering. I know we crossed the line a few times and gave back into the product a few times, but trying to keep that clear line with our team was pretty good as far as I think ultimately for the customers it will help out in the long run.
Yes, definitely.
One of the areas that we're talking about here, which is replication at the moment, this is also something that was enhanced through this project. So when we started this project, pure replication, reverse replication was the recommended strategy. Although we knew that reverse replication had some limitations, and then when you really have an active social community, there's lots of user-generated content going on. The user UGC and the replication can, if not implemented correctly, basically wreck your ability to scale the application out and make it really difficult to achieve your goals of obtaining a really large active community. So, pure replication was one of the ways that we tried to address this limitation. The other is we worked with engineering, and engineering came out. We went to a hackathon about a new framework that was coming out through engineering, which was called the Social Commons Framework. And so the SCF is a new product feature that was introduced in 6.0, and it was actually put out before that in a feature pack. And this is one of the ways that we kind of reduced our overhead on the replication. When we started the project, we had to go into this peer-to-peer. That was the only solution we had pretty much for everything. After the hackathon and we talked it out with engineering, we came to the conclusion. They presented us some options. We talked it out. It was very, very good. But what the result of that, the hackathon was what was called this SCF. So in the SCF, there's a new feature inside AEM 6.0. If you have your screen up there, Tamer, could you show them the social commons where the cloud connector is? So inside AEM now, now the feature is called Social Communities. It's not called SOCO anymore. But if you go to the cloud configuration screen, so cloud services is at the top there. if you look through the new services, you'll see that there's a service called, scroll down. It is called, you missed it, passed it, up. There it is, Social Communities Data Store. So, don't open it. I don't think they need to see our, okay, cool. They don't need to see our configuration or the username. So the Social Communities Data Store. So the Social Communities Data Store operates on the premise of Sling Resource. So, and then it's actually, I think, Sling Remote Resource Adapter. Is that what it's called? Provider. Sling Remote Resource Provider, I believe, or Sling Resource Provider. Is that right?
Have no
All right, let's try that again. So Social Communities Data Store.
You want me to say it right?
Let me look. Yeah, you're like, yeah, exactly. Let me look it up real quick before we start this part. Sling. I knew the name of it. Resource Provider. Yeah, exactly. Okay, so let's start this over again. Okay, so new in 6.0 is the Social Communities Data Store. This came out of this is one of the results of the hackathon and some of the work that we did with engineering. Engineering came up with this principle, this concept that instead of storing all the user-generated content UGC, we would offload that UGC to a central point. It almost follows more of your traditional database model, where you have a database that all your web servers connect to one database for the same data. This completely removes replication altogether. Author and all 4 publishers are pointing to the same remote data source. The remote data source is serving up the same data across them all. It gets updated on system node published node A. It's instantly on published node B, C, D, and author, because they're all pointing to the same remote data source. So this was taken. This came out of the Social Commons framework. This is using Sling Resource Provider, and then what it's doing is it's mounting a point in the repository to a remote API, and that API happens to be a new Adobe hosted cloud service. So this is completely in the cloud, scales well, as every cloud service does that we know of. It offloads some of the responsibility to them, which is always nice, right? It's always good to hand off responsibility, as long as the people are the service is adequate and responds well, which this one does. A couple of the other benefits besides, so what we did is this came out in, I think the hackathon started in October, which was maybe 1 month before we went live with the first communities.adobe.com site. So in January, which was just 2 months in to the publish of the public communities.adobe.com, we'd switched over to Social Communities Framework and the Social Communities Data Store as our backend provider for most of our UGC. So what this means is instead of having peer replication replicate every like, every review, every topic, every comment, all of those items are taken care of through the Social Communities Data Store. So how it works is when something's stored at a point that's under control of the Social Communities Data Store, what happens is it looks at the Sling Resource Provider, and it will go and treat it like a JCR node. Well, not JCR node. It will treat it like a resource, and then that resource is fetched remotely and brought back down. One of the caveats, one of the tricks that we had to work with, or one of the gotchas that we had to do, was you can't really rely on the JCR node API anymore. You have to deal with things in a resource and value map sense. When you deal with things at the Sling resource level and then convert your properties over to value maps, it makes it very generic. It was a little bit of overhead. It wasn't too bad, but that was one of the gotchas. Was we couldn't go node.get property or anything, because nodes don't exist anymore. You're above the storage layer. You're at the resource layer, and that resource is pointing to a remote storage. I think I've gone way too verbose on that, but it really helped us to offload a lot of our replication overhead onto this cloud provided service, and we're putting in more and more data inside this community's data store as we go forward. Did you have anything you wanted to add to that?
No, you covered it really well.
Way too well, way too verbose.
Yeah. It worked.
It works. It's great. It works. You're gonna love it. Try it out. One of the really cool extra features you get out of using the new SCF framework is the ability to everything's taken care of. There's a very nice service layer that's installed for all of the stuff that's stored as UGC. We really like the ability of being able to call services to get at our ratings, our reviews, our discussions. Moving to more of a service data service model helped us out a lot. And that came into the project about 2 weeks in, or 2 months in. Sorry, we had maybe 1,000 users on the system. After we were able to scale. I would say we gained when we went from the regular replication strategy. We switched over to the social communities data store. I think we gained about 40% or more in the throughput of our site as a whole. There's a lot of other facets that are involved in our site as a whole that it contributed to that overhead. But, it was a pretty significant gain overall.
I think with replication and with engineering, the same process we had coming back, working really closely with Adobe Social was really beneficial for both teams. I know we changed some of our stuff as they built it, and even some of the stuff we initially built, once they came out with the product, we would adapt theirs and kind of get rid of ours. A discussion section of Cush actually was built off UGC and now is completely off UGC and uses Adobe Social. That's a perfect example. As the partnership we had with Adobe Social. We also
it's not called Adobe Social anymore. So sorry, but to correct you there, but originally that was the name.
Social
so that's one of the problems with working with these products before they come to public is like the names of them change 3 or 4 times by the time they get out, and then in your head you're thinking, oh, it's this, and then you're like, today I had to actually reference and look at that Adobe Communities Data Store listing because I couldn't remember what it was called. They've changed the name like 3 times, so that's one of the problems of working with pre-release software. It was called Adobe Social. Now it's called Social Communities Data Store.
It's still considered the Adobe Social Cloud, though.
Yeah.
So working
well,
with the
I guess,
social...
I guess you're right. They're calling it the Adobe Social Cloud. Moderation is handled in the Adobe Social. So once you use the Social Communities Data Store, that does give you the ability to run the advanced moderation workflows through Adobe Social, which we are doing. Yeah, it gets kind of muddled, doesn't it? Between the two. And then the word Adobe Social is in here like 3 times. So
exactly.
I'm sorry for correcting you. It's all correct.
No, well, the social platform or framework, social communities data store. Really, what came down to it is the teams worked really well together. We put a lot of their functionality in real world. And we're able to hit it, see its speed, like you were saying. That 40% increase or 40% savings was through struggles of going back and saying, hey, this is working this way. And then also them optimizing it as well and kind of working hand in hand with the team. And that's really what was the benefit of this project above all. The collaboration.
Right, and we did go back and forth on that, as I remember before. And what was great is, again, like you said, it was before customers got a hold of it. We did go back and forth with engineering on 3 or 4 big issues. Actually, I think about 5 issues, because I remember that there was an issue that I had where I wanted to use the new components on a form-based resource. And they hadn't considered that yet, so we had. I think there's 4 or 5 things that that we found when we put the the idea to use and got back to them, and we even made an optimization pass on the service with them at one point to bring the speeds up.
Yeah.
So it was a good collaboration, and it keeps our customers from having to feel that pain, right?
Exactly.
Point those things out.
Exactly. And so that is the same thing with the replication strategies. That's the same thing with the social aspect of the site. So for both of them, that was a huge benefit for the Cush team as well as the respective teams, getting the benefit of real world experience in a project that's front facing, as you could see live, and users are able to access it. The headache kind of falls on the social as well as the engineering team, but on us as well, and everybody's in there to improve it. So it's really good, healthy collaboration.
Yeah, it was really good. Well, I think that does it for today's episode or chapter in the Cush trilogy. It's not actually a trilogy; it's more of an odyssey, I guess. There's going to be a number of episodes that are going to be done. We're going to talk about things fun, so entertaining and fun things like caching strategies that we used, what we learned during the caching strategies, optimization of our code and objects within our code. That's a nail biter. Stay tuned for that one. Let's see. Search and search optimization, the patterns that we came out with there. Let's see, what were some of the other topics we're going to cover? Caching, search, object optimization, some of the UI factors, some of the UI stuff. We're going to talk about some of the UI patterns that we used. The move to Sightly, from using what was called the use bean pattern to the Sightly pattern in the Sightly hackathon.
Oh, handlebars as well. Handlebars.
There'll be a riveting episode on social communities framework and how we use the new social communities framework, or social commons framework. Sorry, again, something that probably changed names, or I just made up a name. I'm not sure. We'll be talking about how that was used and how we overrode it and extended it to use it in our solution along with the handlebars, the new handlebars templates that are in there. And then how we also used handlebars in the other sections of the application with Backbone to improve a lot of the performance. Plenty of good topics coming in the future. So stay tuned, and we look forward to sharing more information with you post-haste.
Thanks for having me.
Yeah.
Thanks for having me, Dr. Ben.
We're gonna have Tamer back on a number of times, so you'll be getting a lot of Tamer, which is a good thing. Cool. All right. Out.
The Benj out.
Heidi ho, David DeBenj here. You know where David DeBenj is coming from, right? That terrible thing I did down at the Max. I don't know if anybody saw that video, but anyways. Oh man, you suck. You're not even recording? Oh, you're no good at all.
Damn it.
What?
My recording stopped. Oh man, Dave blows it again.
Woohoo!